Okay, welcome back, and today we're going to talk about dependent samples. So now, up until this point, we've been talking about two populations and comparing either two means or two proportions, but the assumptions we've made are that they are independent random samples, okay? So now what we're going to do is we're going to take that assumption away and say that what if we have dependent samples? What happens then? Well, that's where the matched pairs design comes into play. And that deals with dependent samples, okay? And so what we're going to end up doing is we take two samples. If they are dependent, right, then there's some sort of relationship between the two, genetic or otherwise. If we find that we have dependent samples, we can't do a two population test. So what we do is we transform it into a one sample test. And I'll show you how we do that. Okay, so let's start there, and I'll explain. So let me talk about it. Okay, so it says, now in this case here, just to give you some examples, it says, if you want to study whether or not a medication helps lower cholesterol, researchers might take a random sample of patients and measure their cholesterol, then put them on the medication for, let's say, 6 weeks, 2 months, and then they come back and they measure the cholesterol levels at that time. Well, in that case, we've got two samples. We've got the sample of blood work before they were on the medication, so that's the baseline. And then we've got the blood work after they were on the medication for, let's say, 2 months. And so we've got two different samples, but it's from the same population, right? It's from the same subjects. So it's dependent, right? It's dependent on the subject, right? So that's a good example there. So the typical experimental design that we use is called a matched pairs design. Okay, so here are the following conditions that must be met for this to be reliable. Okay, so 1, simple random sampling is used. 2, measurements are drawn from the same pair of individuals. Differences are calculated for each matched pair. That's where the idea of matched pairs comes in. Either the population of differences are normally distributed, or else the number of differences is in the sample is sufficiently large excuse me, to ensure that the sampling distribution is approximately normal. So again, either the population is normal or we have to have a large enough sample size. In other words, the number of pairs has to be large enough, okay? So, and again, we're going to look at that in a moment. Excuse me. So here's what we're going to do. If we have this situation where we have a dependent sample, we're going to change it to a one sample. And how we're going to do that is we're going to measure the differences between the two samples. Since they're dependent, we're going to take the differences. And what we're going to do is we're going to collapse the two samples into one sample of differences between the two. So what we're end up going to do is we're going to have one sample of differences. And then what we're going to do is we're going to take that sample of differences and we're going to do a one sample test on the differences. And since we don't know the standard deviation, we're going to use a t-test. And it's always going to be a t-test. So we're going to do a t-test on the sample of differences. And that's what we're going to do whenever we have a dependent sample situation. Okay? So let's talk about that a little bit further. So now, here's what we have. So here's the notation. We're going to use d bar to be the mean of the differences. Okay? So the differences are going to be notated with D. So each one of the D's. So D's are the differences, right? Let me do it this way. So D is going to be each individual differences, right? Those are going to be the difference, which we're going to say is like, let's say the before minus after. Is it? Let me see how they do that. Yeah, before minus after. It really doesn't matter which direction as long as you're consistent. So we can define the difference between the two samples for each individual as D. And so each person is going to have a difference, a before minus after. Okay? And then what we're going to do is we're going to take the average of those differences and call it D bar. So it's going to be the mean difference. Okay? Now, we're going to find that this has this particular distribution. And from the central limit theorem, we're going to use mu sub d. Okay? So mu sub d, or excuse me, mu sub d bar. Because we're going to look at the sampling distribution of d bar. Because this is the sample mean difference. Okay? So now, for the sampling distribution, the central limit theorem, we're going to get the mean standard deviation of the sampling distribution for d bar. And what we're going to find out is mu of d bar is going to be equal to, well, mu sub d. And the standard error of d bar, so because we're using the sample, so it's going to be sample of d bar is going to be equal, you guessed it, s sub d over the square root of n, which is the number of ordered pairs or matched pairs. So now, the formula for this is a t statistic. So watch this. So now, if we use the t statistic and we use the formula, what do we get? Well, remember, it's the observed value. What's the observed value? D bar minus the mean of d bar, right? Well, we're going to show you what the mean of d bar under the null is in a moment. Okay? Divided by the standard error of d bar, which is s of d, right? Divided by, excuse me, not d bar here, mu sub d, divided by the square root of n, which, again, n represents the number of pairs. Okay? And so this is the calculation for our t statistic for doing the one sample t-test on the differences. Okay? So now, we're not going to really use this, right? I'm going to show you it, but we're not going to use this. We're going to use the calculator. Okay? Now, under the null, right? So again, here's how we do it. Okay? Again, under the null hypothesis, it's always the same. There's no significant difference, right? So there's no change. So what should all of the d's be close to if there's no difference between before and after? It should be 0. So that's what we're always going to assume. Okay? So in this case, the 3 sets of hypotheses will be this. And I want you to make sure you pay attention to this. So in this case, it's going to be mu sub d is equal to 0 versus mu sub d is not equal to 0. Or mu sub d is greater than 0, or excuse me, greater than or equal to 0 versus mu sub d is less than 0. Or finally, we get mu sub d is less than or equal to 0 versus mu sub d is greater than 0. So, and again, why? Because we're looking at the differences, right? So under the null, now notice under the null, we're always going to assume that the mean of all of the differences is 0. So this goes away. And so what happens is we just get d bar divided by s sub d over the square root of n. And that's our test statistic. Now again, what we're going to end up using is we're going to end up using t-test. And what we're going to use t-test on is our list of differences. And so I'm going to do an example to show you how this works. Okay? But that's the idea behind doing a matched pairs test. So you have to do it this way. You cannot try to use a two-sample test on this because it's wrong. It'll give you the wrong answer. Okay? So how do you know whether you're dealing with a dependent sample? By the wording and by the setup. Because the setup is going to give it away. Am I using the same person in both samples, like before versus after? Is the same person operating two different machines? Okay? So those are the key things you look for in the problem to help you decide whether this is a dependent sample situation. Okay? So, and again, it'll be obvious. You practice it a few times, you'll be able to see it very quickly. So let's do this example. It says a study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown in the table. So here's the subjects. Okay? So what we know is here's 1, 2, 3, 4, 5, 6, 7, 8. Okay? So now okay. So here's before and after. So these are going to be the lower scores represent lower pain. Higher scores mean they felt more pain. So this is before the hypnotism. This is after the hypnotism. So we're looking for a decrease in the pain level that they feel. Okay? So keep that in mind. So now, here are the numbers. So we got so there are the numbers. Okay? So what I'm going to do is I'm going to calculate the differences. Now, again, it really doesn't matter which way you calculate the differences as long as you're consistent with what you're trying to do. So here's the thing. What they want to do is it says a lower score indicates less pain. The before value is matched to an after value and the differences are calculated. Assume that the population of differences has a normal distribution. Using a 5% level of significance, is there evidence that the sensory measurements are lower on average after hypnotism? So if the values are lower on average, then we would expect that if we define D as let's say before minus after, what would we expect these values to be? If indeed it works, if the hypnotism works, then we would expect that if we subtracted down before minus after, these values should be positive. So the average of the differences should be positive, right? So that tells us that our null and alternative hypotheses, or hypothesis should be this. If they work, then mu sub d should be what? Greater than 0, based on the way we're subtracting. And so the null is less than or equal to 0. So these are going to be the hypotheses we're going to use, okay, based on this, okay? I hope that makes sense, okay? Now, let's subtract. So now I'm going to subtract, and I'm going to write these numbers in. So now I need to calculate the differences. Oh, by the way, no, we don't even need to do this. What I'm going to do is I'm going to put this into L1, and I'm going to put this into L2. And what I'm going to do is I'm going to put those values into my calculator, and then I'm going to use L3 to calculate my differences. And then what I'm going to do is I'm going to do the t-test on L3. That's what I'm going to do. Okay. So first of all, let me put this in the calculator, and you do the same, and then I'm going to erase this, and we'll go forward. So the first thing I'm going to do is do stat edit. So let's enter. Now I'm going to put my before list in first. So L1 will be my before list. So 6.6, 6.5, 9.0, 10.3, 11.3, 8.1, 6.3, 11.6, and that's it. So I got my 8 in there. So now I'm going to do the after list. So L2 is going to be my after, so I'm going to do 6.8, enter, 2.4, 7.4, 8.5, 8.1, 6.1, 3.42, and that's it. So I make sure they match, okay, so I didn't make any mistakes. So now I'm going to quit out of this. Now, here we go. Now I'm going to erase this, and again, I'm assuming you guys already have this down. So now I'm going to start the hypothesis testing with this data, now that we know what we're doing and how we're setting it up. So now, my hypotheses are going to be the same, right? It's going to be this. Mu sub d is what? Greater than or equal to 0 versus mu sub d is less than 0. Why? Because I'm defining d as before minus after. So based on this, if the claim is correct, right? If hypnotism works, I should see, oops, wrong. Oh yeah, no, it should be positive. Yeah, this should be positive. Sorry. There we go. So if the claim is true, right, and hypnotism works, then I would expect that the difference in pain level should go down, which means the higher minus the lower should be positive. So I should have, oh, I hit it right the first time. Greater than 0. Okay, anyway, sorry. Long day. So again, let me explain that one more time. So if the claim is true, so if the hypnotism works, then we should expect to see a decrease in the pain reception, okay? In them feeling pain, I guess. So it should go from a higher number to a lower number on the pain scale. So that means if I subtract these, I should get something bigger than 0. So that's why this is going to be set up this way, okay? Now, the next thing is I'm going to assume that mu sub d is 0. Why? Because I'm assuming the null is true. No significant difference. So 3, now this is where I'm going to put my data in. So now L1 equals my before data. L2 equals my after data. And L3 is equal to is going to be equal to what? My L1 minus L2. Okay? And of course, my alpha level for this test is 5%, so it's 0.05. Okay, so now, since it's a dependent test, okay, and I know that the population of differences is normally distributed, that's what they gave me, I know that I'm going to use a t-test on this because it's a dependent sample. So what do? I'm going to first calculate the differences. So what I'm going to do is I'm going to go to my calculator, and I'm going to go to Stat Edit. And what I'm going to do is I'm going to highlight L3. Okay. So notice here that I have my L3 highlighted at the top. Okay. So that's what I'm going to do. Now I'm going to type in my formula. So I'm going to do L1 minus L2. So I'm going to do L1 minus L2. So notice at the bottom there, okay, I have L3 is equal to L1 minus L2. And notice that in L1 I have my before data, and in L2 I have my after data. So now when I hit enter, watch what happens. Okay, so if I hit enter, there's all my differences. So now what I'm going to do is I'm going to do a t-test on L3. So now, that's where we're going to come here. It's going to be just a regular t-test, and I'm going to put L3 in here. Okay? So now, I'm going to walk you through how to do this and how to understand this. So I'm going to quit out of this. I'm going to go to Stat Test. I'm going to do t-test. Now, I'm using statistics, or excuse me, data. I'm going to use data. Now, under the data menu, the first thing it asks me is mu sub d, or excuse me, mu sub 0. But realize it's mu sub d. The calculator doesn't know you're doing a matched pairs or a dependent sample. Okay, so this will always be 0. So just put in 0 for that. Then the list, that's where you're going to put L3. So second 3, hit enter, and now frequency leave as 1. Now the alternative hypothesis is greater than, so we're going to choose greater than, and now calculate and look at that. Here it is. So now, my T star is equal to 3.036, and my p-value is equal to 0.0095. Okay, so now if I use that, now I can use the p-value method, and I can test this and make my comparison with the p-value. And so p-value is equal to 0.0095, and then my alpha level is 0.05. So alpha is equal to 0.05. And so is my p-value less than alpha? Yes, it is. So step 6 is what? I'm going to reject the null hypothesis. Now, just so you know that the formula works, if I calculate my T star here using the formula that I would use in this case is going to be my D bar over what? It's going to be my S of D bar divided by N. Now here's the thing. I'm going to use 1 var stats on my sample of differences, L3. So watch this. So I'm going to go to stat calc 1 var stats, and I'm going to put in L3. Now Now, well, guess what d bar is? So 1 bar stats on L3 gives me a d bar of, now on the calculator it'll say x bar, but realize it's d bar. So it's 3.125, 3.125, and my S sub d is 2.911. So 2.911. Okay, now, all I'm going to do is plug this in here. Now, what's my n? N is the number of pairs, which is 8. So n is equal to 8. So this is going to be 3.125 divided by 2.911 divided by the square root of 8. Now, I wonder if we get the same thing. So I'm going to cross my fingers. 3.125 divided by 2.911 divided by the square root of 8. And look at that, we get 3.036, the same answer. So it works, okay? So, but again, I would just use t-test, okay? Don't have to memorize the formula, you just use t-test. And so now we can go to the final step, which is our conclusion. And so now, based on the result of our test, we reject the null hypothesis, which means that we have strong evidence to support the claim that hypnotism works in reducing pain, okay, on average, okay? And that's it. So now that, I only want to do one example for that. They're all going to be pretty much the same. Just realize what you're looking for. And so now that ends for dependent samples. So anytime you have a dependent sample, this is the steps you're going to go through. You have to first calculate the differences and then find what the average distance, the average difference is. And then you're going to treat those differences with a one sample t-test. And then you just compare your p-value the same way we always do. Okay? So that's it. See you next time.